Hi everyone, welcome to 7.7 Products and Quotients of Rational Expressions. So we are going to simplify, and the name of the game today is going to be Factor and Cancel. So guess what? We're doing more factoring. Go figure. Okay? So we're going to just focus on the multiplying and dividing of rational expressions, all right? And we're going to talk about factoring and go figure canceling. So let's just jump right into our first example here. Okay, now, so these rational functions, they're just fractions, right? And when we multiply and divide fractions, we have to think about the same rules here. The only difference is now each numerator and denominator is a polynomial, okay? So what I see here in this first example is we are dividing. Okay, so when we have a fraction and we divide it by another fraction, what we really can do is change it to multiplying by the reciprocal. Okay, so what's this really going to look like? Well, if we go ahead and factor at the same time, so when I factor this guy here, x to the fourth minus 27x. So we're going to pull out an x, and we're left with x cubed minus 27. All right, we'll have to continue, but that's good for now, okay? When we factor x squared minus 9, hopefully we're good. We know that's a difference of squares, x plus 3x minus 3. Okay, so now we're going to change it to multiplying, and now our denominator, x plus 3, becomes our numerator. And at the same time, we can factor it, but x plus 3 is as good as it gets. All right? And now we're going to factor the x squared plus 3x plus 9. All right? And what do we get there? Well, that's just going to be nothing. We can't factor that. That stays x squared plus 3x plus 9. Okay? But what we should notice is this guy is not fully factored yet. That's a difference of cubes. So let's go ahead and factor that completely, and then we'll go from there to figure everything out. All right, so we keep that x on down for the ride. Difference of cubes, we have x minus 3 times the quantity x squared plus 3x plus 9. If you're still questioning how I got that, make sure you come in for help. Okay, my focus today isn't the factoring, it's more of how we simplify these expressions. Okay, so now I'm just rewriting all the other aspects. And then we have that final denominator of x squared plus 3x plus 9. Okay, so now the key is we can only factor, or we can only cancel factors, not terms, okay? So that's why we have to factor, cancel, cancel, cancel. So now I just go through, I say, okay, I have a solo x in my numerator. Do we have a solo x factor in our denominator? No, we don't, all right? And then we can say, okay, we've got a x minus 3 in our numerator. Do we have an x minus 3 in our denominator? Yes, we do. So we can go ahead and cancel those guys. All right. Next, we have a factor of x squared plus 3x plus 9. We've got one of those in our denominators as well, so we cancel those. And then finally, we have an x plus 3. We have an x plus 3 in our denominator, so those cancel as well. So then to get to our final answer, all we have to do is say, okay, well, what do we have remaining? And we just have that x. So our final answer is simply x. So this rational expression simplifies to just x, all right? So what I want you to do is I want you to now try this next example. But note, we're just multiplying these two expressions together. So we don't need to change it and flip anything on this guy. So go ahead, pause the video. I want you to factor this completely, all right? And then simplify it, all right? Go ahead, give it a try. Okay, so hopefully you were able to factor this numerator here in red. There's 4 terms, so you had to group it, okay? In the end, you should get 3x minus 2y times x plus 2. I kind of showed a little bit of work here. Factoring the denominator here in blue, you get 3x minus 2y times x plus y. This guy, x minus 2, that can't factor any further, and we have a difference of squares here in green. So now when we go through and we cancel everything, the 3x minus 2's cancel, and x plus 2 cancels, and the x minus 2's cancel. So in the end, it leaves us with nothing in our numerator, so really we have 1, and our denominator is x plus y. Hopefully you got that one okay. Now, if we move on to this next example here, all right, and first I notice it's strictly multiplying, so I don't have to worry about flipping anything, all right? But what I do need to worry about is the factoring aspect, okay? So I take a look here, and I've got 4 terms, and I try to factor it by grouping, okay? So just kind of quickly going through, if I try to group it, I would take out an x squared in this first group, leaving us with x squared minus 4. And I would take out a minus 3 in this next group here, and that would leave us with x minus 6. But since these two don't match, that means we can't group it. So what do we have to do? Well, hopefully we remember, oh, we got to use some synthetic division. We need to go to our calculator. So I'm going to pause the video a second, and I want you to plug this into your y equals, and I want you to pull a 0 out, okay? And we'll go through synthetic division, all right? So go ahead, try to do that, and I will do the same. We'll come back and check. So what I found is, well, one, I noticed there were 2 zeros that I could have chosen. However, I am just going to work with, I'm going to start with the first 0 of -2. All right, so I'll go through this really quickly just to get to the factoring, and then we can factor the rest. So I don't need any placeholders. We have 1, -4, -3, 18 going across. As we go through, we drop the 1, multiply to -2, add to -6, multiply to 12, add to 9, multiply to -18, add to 0, that's good. So now if -2 is a 0, we know x plus 2 is our factor, and we are left with x squared minus 6x plus 9 remaining. So if we factor that guy completely, because this factors further, we're going to have x plus 2, and then that's going to be x minus 3 quantity squared. All right, now continuing on and factoring the rest, this next one, this next guy, x squared plus x minus 6, hopefully we recognize how to factor that. We're going to have x plus 3, x minus 2. Continuing on and factoring x squared plus 7x plus 12, we will get x plus 3, x plus 4. And then finally the last guy there, factoring x squared plus x minus 12, we will get x plus 4, x minus 3. Okay, so now we can go ahead and cancel everything that is able to be canceled. And when we do that, we can cancel one of the x minus 3s, so we'll still be left with an x minus 3 here. We have an x plus 3 that can cancel, the x plus 4s that can cancel, and what are we left with? Well, we are left with x plus 2 times x minus 3 in the numerator, and we have an x minus 2 in our denominator. Now we can always leave our answer in factored form. There's absolutely no reason to multiply these factors out. You're just creating room for potential error. All right? Okay, moving on to the last example here. This should be a quick one. All right? What I do notice is that there is a division sign here. Okay, but then over here there's a times, all right? So the only one I have to worry about changing is this guy here. So change that to a multiply and switch the numerator and denominator of this one only, okay? Since this guy right here, x plus 5 over x plus 3, this rational expression portion is preceded by a multiply, we don't change this guy, only anything that has a division right in front of it, okay? So we could go ahead and rewrite this. We have x plus 3, and that's as factored as it gets, so I'll put parentheses around it. We have the x minus 7. I'm going to change it to multiplying. Now I'm going to change the numerator is now going to be x plus 5, which doesn't factor any further. Our denominator is now x minus 7, which again doesn't factor any further. And we keep that last expression there. X plus 5 doesn't factor any further, and neither does x plus 3. So now we're ready to cancel, cancel, cancel. So as we do, I notice we've got an x plus 3 in the numerator and the denominator, and that's the only thing that cancels. So what are we left with? We are simply left with x plus 5 times x plus 5, which we can say x plus 5 squared, over x minus 7 times x minus 7, so we can say over x minus 7 squared, again leaving our answer in factored form, and we are done. All right, so if you have any questions or if you're still struggling with the factoring aspect, make sure you ask your teacher. Otherwise, have a great day, guys.